So this is geometry lesson 92. So we're skipping some, going on to 92. I'm not giving notes. What we're going to do is we're going to work the practice together. 92 is due Monday the 13th, Monday, April 13th. So lesson 92, again, not giving any notes. So I'm going to go ahead and give you the assignment on it. You're going to do the warm-up on page 600. We're about to do the practice together. It's practice A through D. We're going to do it together. And then you're going to do 2, 5, 7, 14, 17, 19, 24, and 29. Again, there are no notes. No notes. Warm up. We're about to do the practice, and then 2, 5, 7, 14, 17, 19, 24, and 29. Because this lesson, you're really not learning anything different. You're going to actually use the slope and the distance formula to prove something about a quadrilateral. Okay, so on practice A, this is on page 602, so make sure you've got your books open looking at the practice. We want to prove that the quadrilateral CDEF is a parallelogram by determining the slope of each side. So we're using slope on A, okay? So I'm going to write down the coordinates for this. Actually, A is not on there. The coordinates, coordinate C is 1, 0. Coordinate D is -1, 4. Coordinate E is 3, 1. And coordinate F is 5, -3. So what we have to do, so there are my coordinates. C is 1, 0, D is -1, 4, E is 3, 1, and F is 5, -3. Those are in your book. So we want to prove that this is a parallelogram by showing the slopes. So slope formula, M is y2 minus y1 over x2 minus x1. So what we want to do is we want to show opposite sides parallel. So DE is opposite of CF. So we're going to find these slopes. They need to be the same, or this is not a parallelogram, okay? So there's my slope formula. I'm going to do DE and I'm going to do CF because those are the sides that are opposite and they need to be parallel. And then we'll show the same thing about the other two sides, that they have the same slope. So DE, so slope formula, 1 minus 4 over 3 minus -1. That'd be -3 over 4. 1 minus 4, 3 minus -1, -3 over 4. So CF has got to be -3 over 4. It doesn't work. So CF, sorry, I need to go to F. I was looking at C. C and F. So -3 minus 0 on the top, and then 5 minus 1 on the bottom, which would give me -3 over 4. So that shows that DE is parallel to CF. So that's what we show. And again, that's nothing new. You know how to find slope formula. You look at the picture and you can see that DE has to be that DE is opposite CF, and that's why those need the slopes. Okay. Then we have to use the other two sides, which are CD and EF. So again, we're going to find the slope. For CD, we're going to find the slope. So it'll be 4 minus 0 over -1 minus 1, which would be 4 over -2, which is -2. So that slope's -2. Sorry, I didn't show that. There are my points. So 4 minus 0, I put 4 minus 0 on top. -1 minus 1, -1 minus 1. So 4 over -2, so it's -2. Then we look at EF, right there, EF. So -3 minus 1, -3 minus 1. 5 minus 3, 5 minus 3. So that's -4 over 2, which is -2. So that shows CD is parallel to EF. Therefore, remember that little 3 dot thing I showed a long time ago? CDEF is a parallelogram. And remember, I let you do the parallel sign with the gram after it to show parallelogram. So that's the way you do it using slopes. Again, nothing new because you should know how to find the slopes. Okay, so that's A. Now let's look at B. On B, we want to know if that's a trapezoid. and explain how you know. So we're going to show our work. Well, for a trapezoid, you just need one set of sides parallel. Okay, so we just need to show one set of sides parallel. So let me get the coordinates first. P looks like it is -4, 7. That's what P looks like it is. Q looks like it's at 5, 1. R looks like it's at 2, -1. Making sure my scale is right. And S looks like it's at -4, 3. So again, you can get those out of your book. That's just looking at the coordinates there. P is -4, 7. Q is 5, 1. R is 2, -1. And then S is -4, 7. So when we look at the trapezoid in the book, well, we can just find all the slopes. We're just going to find all the slopes again because it's just finding slopes. It's good practice on finding slopes. So again, let me put the slope formula over here. Y2 minus Y1 over X2 minus X1. Y2 minus Y1 over X2 minus X1. So again, we're going to use slope. So I'm going to find the slope of PQ. Slope of PQ. 1 minus 7 over 5 minus -4. 1 minus 7, 5 minus -4. -6 over 9, which is -2/3. Then we'll do QR, because we just need to find one set parallel. So QR, -1 minus 1 and 2 minus 5 would be -2 over -3, which would be +2 over 3, which is not what we need, because that's not the same. Let me make sure I did that one right. -1, 1, 2 minus 5, yeah. Okay, and then we'll do RS, which would be, RS would be 3 minus -1 over -4 minus 2, which would be 4 over -6, which would be -2/3. Okay, so I've got right now PQ parallel to RS. Now those are the only ones that can be parallel. If I find this last one, if I find PS and it's parallel to QR, then this isn't a trapezoid. I can only have one set of sides parallel, and right now I've got PQ parallel to RS. So now I try PS. So PS is the first point and the last point. So 3 minus 7 over -4 minus -4. 3 minus 7 over -4 minus -4, which would be -4 over 0, which is undefined. Okay, which is not the same as 2/3. So, therefore, it's a trapezoid. Okay. We are actually not going to do C because I just think it's overkill of the distance formula. What you'd have to do on C is you'd have to find 8 different distances to show that they're congruent, 8 different distance formulas. So we're not going to do that. We're actually going to skip C, and we're going to go on and look at D. So on D, determine if the plot of land is a trapezoid. So again, we want to show, it's G, H, J, K. We want to show slopes again. So slope is Y2 minus Y1 over X2 minus X1. And again, we could do C. I just think C is overkill. It's 8 different distance formulas. I think you know the distance formula, and I also think you know slope, but I did want to show you how these worked to show slope. So coordinate G is 8, 5, it looks like. G is 8, 5. H is 7, 2. H is 7, 2. J is 2, 2. And K is, all right, 4 up 8, it looks like. Okay, wow. G is 8, 5, H is 7, 2, J is 2, 2, and K is 4, 8. So then we do slope. Find slope of all of them. So I'm going to start with GH. So that would be 2 minus 5 over 7 minus 8, which would be -3 over -1, which is 3. So that's GH. Then I look at HJ, which would be 2 minus 2 over 2 minus 7, which is 0 over -5, which is 0. That's HJ. Then I'll do JK. JK is 8 minus 2 over 4 minus 2, which would be 4 over, it would not. It would be 6 over 2, which is 3. So right now, I have GH at 3 parallel to JK at 3. So this slope is 3, JK's slope is 3, so these are parallel. Now, we still have to check GK. We still have to check that line. So I'm going to go GK up here because I ran out of room. So GK. So that would be 8 minus 5. 8 minus 5. And then 4 minus 8. 4 minus 8. So that would be, what, 3 over negative 4, so negative 3/4. Okay? So I only showed one set of sides parallel, so therefore it's a trapezoid. Okay, then 2 is vertical and horizontal components. We talked about that. 5 is good, 7's good. 14. Okay, I did want to draw out 14 and show you, remind you of centroid. 14 is centroid. So I want to draw out that triangle and remind you of what's what. And we are given that this is A, this is E, D, B, C, F. We know that it's a centroid because we've got congruent marks. I'm not sure that these are exactly the right congruent marks, but you can see it in your book. I just want to show this and remind you how it sets up. So that means G would be our centroid. So remember, there's a 2/3, 1/3 thing. So this is 2/3. So AG is 2/3 of AF. AG is 2/3 of AF. GF is 1/3 of AF. So that's a couple of different ways you can show that. And then 2/3 and 1/3. So if we're looking at BD, BG would be 2/3 of BD if you had the whole thing. And DG would be 1/3 of BD, the whole thing. Okay, so that's the way that sets up, okay? So then CG is the 2/3 part, GD is the 1/3 part. And we talked about if you have the 1/3 part, you can multiply by 2 to get the 2/3 part. Anyway, that's how that sets up, and that should help you get your answers on number 14. Then on 17, I wanted to set up the triangle for 17. Let's see, you've got a plane takes off and flies at an angle of 30 degrees from the ground. So that's like an angle of elevation. And then at some point he gets 3,000 meters above. It says use trigonometry to find the horizontal distance. So you want this distance. So you could see this as a 30, 60, 90 degree triangle. You've got the short side, you need the longer side. Or since you've got opposite and adjacent, you could do tangent. Doesn't matter, or you could see it as